Okay, guys, so continuing from the earlier video, patient star schema and snowflake schema. So you see here, if we have to draw an ER model of this, what we did here, we can simply say patient dimension, laboratory dimension linked to patient laboratory fact, something like this. So this is nothing but a schema or a representation of a data mart. Now, star schema is when all the dimensions have just one fact. So when I say all the dimensions will have just one fact, that would mean that, for example, this is patient, insurance, credit card, laboratory, and doctor. So this fact would be a table which will have a fact ID, nothing, a basic ID. It will have a PID, it will have a insurance ID, it will have a credit card ID, it will have a doctor ID, and an LID. So that way, this fact has its links connected to all the tables. So if you want to derive any information from even two of these, you can straight away go to this fact and just query these two, and you'll get the result whatever you want. This is star schema. Now, in practical implementation, schemas are rare because the reportings are big. So this is a data mart. When you connect, if I say this full data mart is D1, right? So in a snowflake schema, have you seen a snowflake? Snowflake is something like this. It will have in a much more beautiful sense, obviously. So snowflake is something like this. So think of a schema in which there are such small data marts like this everywhere, and they are connected to different facts like this, and then these two facts are connected. So snowflake schema is when various facts are connected to various dimensions. That's how, and this is basically the practical implementation in an industrial environment, in a reporting environment where slicing and dicing is done on these facts. Now there are various things like types of dimensions, type SCD type 1, SCD type 2, and then slowly changing dimension, SCD is slowly changing, and then facts like factless facts and other stuff that you need not go into detail right now, because this itself should be sufficient for you to model the scrambled CSV with all the data given to you. Okay, so this thing should be sufficient for you to actually go through the scrambled data model. I'll come to next part, which is data cleaning, in a few moments. But before that, I just remembered that I told you that I'll explain why we need ID mandatory in every CSV. Okay, so you might have an intuition that everywhere ID is a primary key. We are joining, so we create a primary key for every column, every row in every CSV. That way, we defeat, even if the all the, because there is a high chance that there are two patients with the same name Vivek with the same disease, obviously in today's days, which is corona. So there is high likability that there would be some data redundancy, but that is not a data redundancy in actual sense, because those two are different patient. If I simply add the Aadhaar card number, that would make those two different. But Aadhaar card number is a very big number. So, and no one can remember that, and it would be really difficult to query a patient with its Aadhaar card number. You can basically type 16-digit code, and how would you get that? And most important thing, it is a personalized information, so it won't be available like for querying you. So that way, ID, which is just a numerical representation of a serial number representation like 1, 2, 3, 4, 5, it is much more small, first thing. Secondly, when you create an index on it, so the way this data is stored in, okay, I'm going to explain this. This would make more sense to you guys. How indexing helps and how it is stored in RDBMS. Okay. For example, there is a table which has got ID, okay, and then various information, name, class, roll number, something like that. Now, when I create a primary key over here, what it does is in memory, it goes and creates an index, two files, index file and data file, index file and data file. Data file will have these three things, all four, five, whatever columns. Index file will have these IDs connected to the hash of each of these rows. That way, when how this helps, for example, there is this scenario in which you have an index and then the data, and then there is another scenario in which you don't have index created, all you have is just the data, right? Now, if I'm asked, just give me the roll number of a student named Rohan in class so and so, what you are going to do is you are basically going to pass through each and every column, going through each and every, sorry, going each and every rows, each and every column. And that way, in this scenario, it will happen. But once you index it, what it will do, it will go and search into hash. It would be really simple to pass through this index file through with the help of hashes and IDs. What will do is simply go through hash, it will find the ID, and just whatever data is in front of that ID, it's going to display that data in front of you. So that's how indexing helps. Paging, indexing, these are all the concepts which just helps computer to run faster, database to run faster. And that should be it, I guess, guys. And let me know if you have any doubts, I can clear it.